any further, but go ahead and put in a marker. We're ready to get going. So today my plan is to go back through the type object chapter here, but instead of the JavaScript conversion that we did, we're going to do Rust conversion this time. So I have VS Code open up here. Let's go ahead to type object, and we want to do what is this going to be? So I think we're gonna have to skip the typical OOP answer. We're gonna go down to the example code that we have here. Sample code. So I'll do sample code.rs. Yes, I know there's no cargo.toml. I'm not doing real compilable code here. I guess like it's compilable. I'm not actually compiling it though. Okay, so start with the breed class. So this is a struct that we're going to create these monsters off of. So we're gonna have a struct breed, and then we're gonna have. It looks like we're gonna store health internally. So health. You know, oftentimes this might be like an F32 or like an I32. It depends upon how it's like what the engine that we need is. Oftentimes I'm using GGEZ, which does want F32s everywhere. So I just sort of get into the habit of using them all the time. And then the attack. So the attack is the attack string. So this would be the attack. This one actually makes sense to be a static stir, and that's pretty much that for that. Let's go ahead and import breed. I'm going to use the sort of the constructor pattern for this. Import breed. Pub function new, and we're going to take in the health, which is an F32, and we're also going to take in the let me think about this, because if I do health, you know what? Let's do I32s for right now. Maybe if I was doing like a game that required F32s for like display and other stuff, I could just convert at that time over to the F32. You don't lose anything unless the I is really high, because F32s can't get the same numbers as I, so I'd have to deal with that. But for this example, it won't matter. And then we're gonna have our attack string. So attack, which is a static string. Static string is literally a string, so like a string literal, like we put into the code like this. It's basically just saying, hey, it's static, it's living in the source code. So the lifetime is basically, it's there. Guaranteed, it's there. And we're gonna return a breed. So the returning this breed is pretty easy. Breed, add in the health, add in the attack. And there we go. We've got the basics of the breed here. Now what we have as well are these two methods, get health and get attack. Now I could pub these, so make them public so you can get access to them, but that might allow somebody to mutate them. So I could just do getters for it too. It really sort of depends upon how C-like we want to be with the pattern here. There's no problem with us doing, okay, so pub function get health, and then this is self, and we're going to return I32. And then we're just going to return self.health. And it sounds like we're also going to have our attack. So hub function get attack self, and we're going to return. So here's where it's interesting. It's suggesting that we return a reference to this attack. However, I think that's what this is, a reference to the attack. But it's also storing a reference to the attack, which is simple. Now there's no problem. I could definitely store this as a reference to this string slice. So I could do something like stir, which this should be fine because it's knowing like, hey, I'm returning this, but it's living in here. I believe that's what's going to happen. So self.attack. Now, can I get this to... Yeah, okay. So I'm getting my errors and warnings. It's just not... Struct is never constructed. Entity. And location. All right, just to make it happy, I'm gonna go ahead and let's close this and actually create a real Rust thing here. So here I am in, where am I? I'm in the game design patterns. Let's go into playgrounds. This is the type object. CD type object, cargo new, and I just want to play with what is it, sample code. I could just do chapter 13 Rust. Open up code here, and this should make it a little bit happier and let me know if there's any errors in it. So let's go into main and replace you all with this struct and everything else. And we can have a function main. That doesn't really do anything. Okay, so now I'm getting everything here. So now it's just saying, hey, we're never constructing this. So we're all good to go, but it's not yelling at me that this is not a good idea. Back to the book here. Okay, so we have our breed. Now the idea of this is that we want to create like a monster. So it's just compare, and so we're gonna hand the breed to the monster, and then the monster can like get information from the breed. And then in this case, like, okay, we just want to get like the attack from this. And if we, we're gonna get the health from it to store off with the default health. So this is essentially default health for the breed. So let's imagine that we're creating like a dragon here. So let's do let dragon breed equals breed new. And we need the health, so I think it's something like 248 is what they used. And then the attack is the dragon roars, and the dragon roars and like fires flame at you, breathes flame. Bang. Okay, so that gives me the dragon breed here. But now I want to create a monster from this breed. So let's go ahead and create another struct here, struct monster. The monster also has a health, which is an I32. And it has, so in this case, we're storing the breed. And I believe like later on, we stop storing the breed and we go to like, there's some other ways to deal with this. But for right now, we're gonna store like the breed that we're coming from. And so there's a choice that we have to make here. Are we gonna take ownership of the breed? So in this case, this dragon breed. Or are we gonna try to take like a reference to this breed? If we do a reference to the breed, we're gonna have to deal with lifetimes, which is not the nicest of things. If I was to do a lifetime here, I would have to put, where is it? I always forget exactly what the syntax of it is because I always avoid them when I'm doing with structs. So I think it's like lifetime A, and then is it A like that? Or is it the other way around? So I defined that lifetime. I'm not using it correctly here. Or I have to have like the turbofish syntax here too. Let's quickly look it up. Rest struct lifetime. Where's the... I used to be able to get the rest by example book like every time Earth fought, no matter what question I asked, but there's so many more resources now that it's not really showing me what I want. So let's go to the, I guess we just go to restlang.org, and I think I can get to the rest by example book down from learn. But wasn't there a rest by example book shown here? Or is that not official? Rest by example. Oh, okay, here it is. Yeah, okay, it's official. It's part of the docs. Rest by example. I must have just have missed it. Okay, so I need lifetimes. And I want structs here. Let's make this a little bit bigger. So we're gonna have a struct borrowed. We have that, and then okay, well it's pretty much like what I thought I had. Take A like that. Oh, I had to save. I keep on forgetting. I have Rust Analyzer now, and it doesn't always do things automatically. I have to save for it to take. Okay, so this allows me to store the monster. So if I do the same sort of constructor pattern that I did above, where we're creating a monster here, so impl monster, hub function new, we're gonna take in the breed, which is gonna be a reference to a breed. And what else are we gonna care about here? Nothing else. And we're gonna return a monster. And so this is gonna be monster. So health, we're gonna get from the breed dot health, and we're gonna store a copy of the breed with breed just the breed. That should make you happy. Implicit deleted lifetimes are not allowed here, so we need to add the lifetime in here too, I believe. So we need to do something like that. But if I do something here, I need to declare the lifetime, which is here. Undeclare lifetime, just put it here. Sort of like walk back with the errors to sort of go backwards, and then we get it. Okay, so now it's happy. So now we have our dragon breed. Let's go ahead and create the monster, the specific dragon from the dragon breed. So we're gonna say let what's our monster? Let's do Danny, do you want to be a dragon? Danny the dragon equals, this is going to be monster new. Then we're going to hand it a reference to the dragon breed. So dragon breed. And so things are still happy here. So they're still compilable, meaning that we have Danny, and off of Danny, we can now get that Danny's health, his default health is set to whatever we set the breed to. But now his health is separate. So if we attack Danny, Danny's health can go up or down. However, the get this attack string is separate, and so if it wants to, if Danny wants to do this attack, so we can print line, and we'll just say Danny dot. Oh, we're gonna have to add in this this attack. So with monster, we're gonna have a get attack method on here. So pub function get attack. Let's get self. We're gonna return a reference to a stir, and we're gonna do self.breed.getAttack. And so here is Danny got get attack. So if I do this and run this now, so cargo run, the dragon roars and breathes flame at you. Okay, perfect. So I mean, it works. We're able to like have like a singular monster breed and share that between. So if I want like many dragons, I can now create them. I can create another dragon at all. Well, I don't have any other names in chat right now. So let's just make up one. We'll make up Sally is a dragon too. So equals monster new and a reference to the dragon breed. And this works as well. I can now duplicate this, and it's now Sally attacking. So no problem. It's maybe not the best. So I've some of the people I've been following online, they say, and these are people like that I trust. So like for example, Icefoxen has said this on Discord several times, and he's made GG easy, and I really like trust, and I like the code that he writes too. If we end up having to use lifetimes, then there might be a better way for us to do this. So this might not be the best way for us to go around it. But let's continue on and seeing if this code examples have a better way for us to do it. So the next thing is we're going to have the breed, and it's going to return a new monster on its own. Okay. Now the problem with this is passing like a reference to itself at that point in time. This is, I don't think this is going to work, but let's go ahead and try this. So in breed here, we can add in another public function new monster, and we're going to return a monster. And so this is going to be a monster new, and we have to get a reference to self, and we're going to pass it in self. Chantilly, good morning. I mean, it's not erroring at me, so it's, you know, we're passing a reference to itself, which is, you know, exactly what monster takes in. So at this point in time, instead of like this dragon breed, you know, having to pass it in here, now we can do Danny and Sally the dragons are created through dragon breed dot new monster. And so if I do that, this should still compile. Yeah, the dragon roars and breathes flame at you. So this is another way to do this. I still am not super happy about it because we have to have those lifetimes on the struct. There's not really anything different here in our monster class. What is there different now? Monster. Oh, right. They did this like friend class, which we don't, definitely not something that we have in Rust. Get attack, returns breed attack, and the monster still is dealing with like getting. We still have our constructor that's storing the health separately, and then the breed. Getting the attack string. Okay, that's fine. Now, with this system, this is not using inheritance through C++. This example here, they're creating their own inheritance system. So we might be able to try this. Let's see what we're doing here. So we have class breed. We have the constructor off of here that's taking a reference to the parent breed. So this is now if we're gonna have not just like, okay, dragon and trolls, but like a parent dragon and like subtypes of dragons. So then we have our health coming in and the attack string. And then we're storing the parent. So storing the parent definitely is going to take a lifetime if we're storing a reference to the parent here. And we're storing the health and the attack separately. Look, well, the attack is a reference. Okay, so if we go back and we do this again, let's sort of refactor here. Our breed now is going to take in a parent, which is going to be a reference to a breed. Then we're going to have our health and we're going to have our attack. That remains the same. But we're storing the parent now, which is meaning that we're now going to have to do, okay, so if we're going to do parent, we're going to have to do a reference to a breed. Well, if we do that, now we need to add in a lifetime for this, which means we had to have a lifetime here declared. What are you upset about? Missing lifetime specifier? Didn't I add you in? Consider using the name lifetime breed A. Wait, didn't I do that? Save. Is it upset about here or? Huh, I can swear let's see, what have I done differently here? Reference thing A. Oh, okay. I don't know what might be the trait impl block. Yeah, okay, it probably is this. I probably need to like add all these here now too. Thank you, Vladinators. Let's do that. Let's just add this in here. And, oh, we need to store it. So we have breed. I guess it's just parent. Cannot infer appropriate lifetime for lifetime parameter A due to conflicting requirements. Does it need to be a different lifetime? I always figured that it didn't need to care, but it may not. Oh, right, because now monster is going to have the breed that has the breed. So we get into trouble here, which makes a lot of sense. And I know that we get to the point where we don't need the parent in this, but let's see if we can fix this really quickly. So you are upset because can infer an appropriate lifetime for lifetime parameter A. Do I need to change you to a different lifetime? Mainly because I'm using A elsewhere. So if I do that, are you happy? No. Missing lifetime specifier. So you're here, we've initialized our lifetime. Oh, is it because like here has its own lifetime too of this breed? Because like the breed and the parent come together. But let's see, we're gonna get health and get attack. We've removed the new monster again. So if I do that, the parent, I don't need to tell you that this is just a reference to parent, do I? No, okay. Conflicting requirements, but the lifetime must be valid for the static lifetime. Expected breed static because of the attack. Because I have 2 lifetimes going on here. Do I have to declare static too? What would that be, like that? I don't think I've ever declared static. I've always just used it. Yeah, like it's a reserved lifetime, so I don't need to declare it. But I guess it's because the lifetimes don't last the same. Wait, did I not return with this? I need to return static B lifetime. I keep on forgetting lifetimes. Let's we could skip down to where we don't need lifetimes anymore, and then that will be good. So basically, the general idea of this example is breed is taking a parent, and now we're going to be able to extract from the parent if there's any information that we need. So in like get health, we're now going to check from the parent. The only problem with this example, as we see here, is that we need to store the parent to be able to get access to it in here for, for example, like self.parent. That means we need to store a reference to it, which sucks. So what we can do is we can just store these without lifetimes right here in here. So we have our health attack. We have our static string, so health and attack. We have our impul. Let's remove all these lifetimes now. In our breed, we're going to take in a parent, and this can be a reference to the breed because I'm not going to I'm not going to store it. We'll get the health and we'll get the attack, and we're going to return a new breed. We're not going to store the parent, but instead we need to figure out how we want to deal with the health here. And this health is going to be we have to pass some number in. Well, if I want to make it an option of us not passing a number in, then this needs to be an option which has an I32. Would it be health is an option? I32? Yeah. An attack is an option that has a static string in it. Now, of course, that makes this extremely upset. What we want to do now is extract out the health. If the health is passed in, we want to override the breed and use it. If we don't have a health, then we want to use the parent. So we could match on this, or we can use the if let. And I think this could be let if I want, let's rename this to like given health or something like that. Given health, given attack. Then we can do let health equals if let. Our pattern here is going to be this sum. Sum given health. Sum health. So we can just do given health equals given health. Okay, so if given health is an option that has something in it, specifically this I32, it comes into here. And I could just name this health. There's some we get run into a little bit of trouble with like having like health. Which ones are we talking about? This variable is created at this point and it's destroyed at the end of this block. So it's not the same as this variable. So there's no overlapping there. So nobody really cares. Except us developers who might get confused by the fact that we have health everywhere and they're not in the same scope. But anyways, what I could do is I could return into health here the health. Else I want to return into health the parent's health. So parent dot health. I think it's get health. And semicolon here. And now we have health being properly stored in. So the idea here is we pass it in a parent and we just say, here, all dragons have this, except for this type of dragon that has this other health instead. But not like only sometimes. Like we get to create like now complicated sets of breeds based upon this system. So let's do the same thing now with our attack string. So we're gonna have a given attack, which is this option. And so now we're gonna do let attack equals if let sum, and this is gonna be the attack equals given not health, given attack. And then it's going to be the attack we return if it's there. Otherwise, it's going to be the parent dot get attack and semicolon. So if you're not used to if being used as like in this specific way, it's a little bit different and a little bit like it can confuse you if you're new to Rust and you're coming in. So if we take a look, if we break this down a little bit, what is sum here? Like if let, this is an if expression here. So it's not just like the normal if statement or if conditional that we're used to seeing in other languages. So if, and I'll come into some in a little bit later when we use this and we like actually create the sub-dragons. So if given health has something in it, it would be specifically this I32. So the given health is this option. So basically extract out whatever's in here if it is in there, and then run this code block, which in Rust, if there's no semicolon, it auto returns the last thing. So I'm returning health. I'm not returning it from the function, I'm returning it into this variable here. Now Rust doesn't have nulls, so we can't just end it there. And that's the reason why I can't just say like, well, this is going to be this or null. Instead, by doing an option like this, Rust forces me to handle, well, what happens if it's not something? Like if there's nothing in there, well then get it from the parent. And because getHealth returns an i32, it's happy. And it knows that I'm going to get something no matter what. Like eventually I'm going to get something proper. And we do the exact same thing to attack. And now we kind of store this in. Oh, we want this to be a static string. So this actually is going to be interesting. We need to now switch given attack out to not return a static string, but a static str, and it returns self.attack. It's going to actually copy it in memory behind the scenes. So there's going to be multiple copies of it potentially. And here we go. We're now able to create this breed based on this. So let's see how we can use this. We have a dragon breed. So let's maybe like make this the base. Let's call this like the base dragon. Equals a breed new. And oh, we also need the parent to be an option too, right? Because what if there is no parent? Like chicken and egg problem here. So you are going to be an option that has a reference to a breed in it as well. Which means this now, we need to like do a little bit more and figure out like, okay, well, if the parent has something in it and the given health has something in it, otherwise we're gonna have to just air out and it's gonna be terrible. So let's see. Here we verify that we have something in health. So we just use this. Now, if else. Now I could just put this in here and just do like another if let. And like maybe that's the right choice. If let parent health. I guess this would be parent equals hold on. We do health. We want to return from here. If let's allow us to return from it because it's just an expression. So we're going to return from if let sum. It's going to be the sort of like the parent. So it's going to be a breed of some kind. So we're going to just say the parent equals parent. So it's going to know that this is a potential reference to a breed. We're going to return from here parent.getHealth. Else, it's still yelling at me because it needs me to cover all the cases because health has to be an i32. It can't be nothing at all. And so if there is no parent and there is there is no health. So therefore there has to be a parent. If there is no parent, we're gonna have to like crash the system. Well, there is a macro for that. We can just panic and just say there must be a parent breed. And that will make it pass because we're handling all the cases and Rust is trusting us. Hey, we want to crash in case there's a problem. We've coded that, we've hard coded that in. Now get attack, what are you upset about? Right, because now it's going to be the exact same problem down here. So we have to handle this as well in our else. And we're going to change this to get attack. So Rust does like make us code a lot of this extra stuff, but it's also there to protect us. So we can't like accidentally run into problems, and that's why Rust is considered safer. It doesn't necessarily mean less code here. So let's come back to this. We want to create our base dragon, meaning that we don't have a parent for this. So let's go ahead and reset this. I'll just copy off this string for us to use later. What is our parent going to be? Nothing. We don't have a parent for this base dragon, so that's a none. This is the equivalent of null in Rust, but because of the option types, you can't actually assign anything to null or none directly. Okay, and then we're going to have the given health. Well, I have to give it a health here. If I don't, it's going to crash the system. So here, let's say 248 is the base dragon's health, and given attack is given attack is going to be this string here. So and I can't just like give it like this. It has to be a specific option. So we're going to do this as a sum, and then hand it 248. And this is a sum, and hand it this string, and then that makes it happy. So now we have our base dragon that has all of this stuff. Shoot City bot, can you make a 5M server? No, I cannot. Well, mainly I don't also know what that is, but yeah. Okay. Wait, is that for Rust the game? We're not doing Rust the game. We're doing programming. I think I played like 5 minutes of Rust the game, and that was it. Okay, so now we want dragon breed, new monster. So we want to create a new dragon based upon this, like a new breed based upon this breed. So it's going to be like a sub dragon from this. So let's go ahead and create. What types of dragons can we have? We can have like where's it, like a green dragon? Green dragon equals breed new. And so now we're going to have the base dragon as our parent. So it's going to be a sum, our base dragon. And at this point in time, we could just say, you know, green dragons, they have the same health. We don't really care about the health. So we're not going to give them any health, but they do have a different attack. So this attack is going to be a sum. The green, the dragon spouts a green flame at you. And you need to be, a reference to the base dragon. There we go with that. Now we're happy again. So we now have a base dragon and a green dragon. These are all different breeds of that. So now we can create specific monsters from these like base dragons. Now, the next thing I want to do is like figure out how to not have any of this problem here, which if we're willing to take a little bit more copying of memory around, we could just have it that the attack is stored in here as well. But let's get back to our examples here. How far did we get? So breed, this is stored, and they actually suggest here that we have in the constructor, we just store everything away, and now we can just return the internal get health, get attack. Okay, so that's fine. Let's now fix so we don't need lifetimes in the monster here. So if I remove you, meaning that we're not going to store the breed. If we're not going to store the breed, then that means we're going to have to store the attack string as a static stir. What are you upset about? Lifetime trait object must be followed by plus. Wait, how did I do it up here? Oh, the reference. I forgot the reference. Okay, so implement. Don't need you. You don't need you. Okay, so new breed. So you can now be a reference to a breed. We're not going to store you away. And so we have health, breed dot health. Where are we getting you from? That's up here. We have this get health. So breed dot get health. And then we're gonna have attack. Breed dot get attack, which returns a copy of that static string. Oh, get attack. I was wondering, like, that's the best thing about Rust is it won't let you go on until you get it right. Okay, so we've got that there. Get attack now doesn't get it from breed, it now just gets it from self. Okay, so with that in mind, Danny is going to be a base dragon. And hold on, it's gonna be a breed. Are we gonna do a new monster off of this impul? I think we removed that. So it's now generating a monster straight from here. It's actually easy. We could still do this off of here. So like pub function new monster. A reference to self because we don't need to mutate it at all based upon this. And we're going to return a monster. And so we're going to say monster new, and it's going to ask for breed, so it's a reference to self. So in here, we're going to have dragon breed dot new monster. So we need you to be a base dragon to begin with. So this is going to be a base dragon dot new monster, like that. And so Danny is a monster. Sally is a green dragon dot new monster. And so now when I say these two different attacks, we should get... Oh, I forgot, there's no... is there a clear? There it is. Oh, we cargo run. Oh, we overflowed the stack. Process didn't exit correctly. What did we do wrong here? Do we have any actual warnings? That's fun. Function cannot return without recursing. Okay, so this function get attack returns a reference to a string self dot get attack. Ooh, that's not good. So what is this? Line 60. Self dot. This is monster. We have attack. So self dot attack. And not a function. There we go. Okay, so the dragon roars and breathes flame at you. The dragon spouts green flame at you. So it's very similar here, but the idea is that we want one type, the monster, but to have like different subtypes without having to like, we've kind of implemented our own inheritance system in Rust without having to build like, try to do any weird tricks with traits or anything else like that. We certainly could do traits with this, but I think like this is an idea that if you want to have some kind of inheritance system that's very basic in Rust, it's possible to do. We just have to do it ourselves. That being said, if we do it, we get the protections that Rust gives us. So we can't like, now we could do like multiple levels, we could do all sorts of other stuff. I don't necessarily recommend that. I think a single level, and it also allows us to like force what types go into it. As you can see, if I did multiple levels, we'd have to go multiple levels deeper with all these like if statements. We could create methods to sort of like delve in here and do that. And that's certainly possible. Now, continuing on, let's say we want to have like some struct that holds the data for these. And then we want to use that data to like construct dynamically a bunch of monsters. So in this case, trolls. Now this is suggesting coming through a JSON file. So we have a JSON file that holds like all this troll information. We can use something like JSON to extract this out. And then we're gonna have to loop through it and figure out, okay, we have the base troll. Okay, the troll archer wants the parent, that's the troll, and this is the troll name. Let's go ahead and extract and like get information, like get that out of there. And I'm wondering how easy that would be in Rust for this. With JavaScript, there's some interesting ways to loop through basically a list of the keys of an object. And I can't remember if I'd have to have a vector. Well, this would be like a struct of these if I wanted to like create this in code, because JSON has to come into that. So if I could do this manually, then I could do it with JSON and like import it. And then the idea is that if you are making a game like this, you can have the designers just play around with JSON, which is going to be easy for them, or build some tool that creates JSON for them. And then we just have to pull that JSON in and deal with it. Now I know with Rust there's also Arson, which I haven't played with yet. Something I want to do. Rust object notation. Is it object Ron? I think it's Ron. I haven't really looked at it besides like, okay, it's more like default with Rust. I don't know if it's easier for like non-technical people to play around with. JSON seems to be okay with that, especially if I then turn it into something like YAML. But if I wanted to try something like this, if I do the parent, I would have to do like a lookup table for what this means. Like I have a string that means go and grab this. I could do an enum of these types, and then we can match on them. That would like potentially work, because I could match on the parent and then say, okay, grab me this one, and like mix together. So I have like 5, 15, I have 20 minutes left. Let's see if I could create, let's create like the library file. So what is this going to be called? This is, We'll just create it in a library file. Lib.rs. So let's create this this sort of like code as like the struct. Oh, what would this is gonna be like the data. So like a monster pub struct. Monster data equals, come on, keyboard, work with me. And so here's where we're gonna have like a basic, we want a basic troll. So we're gonna have the name. Okay, so we're gonna have like this information. So we're gonna have like health, attack, and parent. Well, parent is sometimes there and sometimes not. So that means it has to be an option. So we're gonna have parent, which is an option. And in here, I guess for us, it's gonna be a static string. There's no equal. It's just that. Okay, so then we're gonna have health and attack, but we're having like health is 0 here. I think that's just because if we want, just to make it easier, and it's like, hey, it's always gonna be there. If it's always gonna be there, then we don't have to put them in options. If it's sometimes going to be there, then we do have to handle that. Now Rust, like regardless of which way, Rust will force us to deal with this. So if I do something like we have health, and this is gonna be an I32, and we have an attack, which is gonna be a static string. So let's say they're always gonna be there. What are you upset about? Expected bang. How about a space between keyword struct? That would help. And a comma there would be helpful too. All right, so now it's just yelling at us that we're not using it. Okay, so we have this monster data. So now we're gonna have to create a whole bunch of these and figure out how to use it. So if I have, let's say, like a pub function, like setup. In here, we want to take our monsters, and this setup is what we're actually going to run. So let's actually set up here. So use, what is this? Chapter 13 Rust setup. Oh, do I have to do like the extern crate trick here? I can't. I always. Extern crate that, and then I can use chapter 13 setup, maybe. No setup in the root. I have pub function setup there. In main, can I run this? No setup in the root. Okay, so unresolved, import, setup. I think extern crate might be wrong. Is it like crate that I have to do? Chapter 13 Rust. That's what I named this, right? Ergo.toml. Yeah, chapter 13 Rust. And then colon setup. Well, I forgot how to like, man, I keep on forgetting this every time I like start a new project too, and I always have to look it up as well. I'll ignore it for right this second, and then we'll come back to it. once we get there. But I think the general idea, and this is giving me highlights here, so that's really all that matters for this code. Because generally, if Rust doesn't give you errors, then it's probably going to compile and be fine. So if we have this like setup here, we're gonna want to create a bunch of this monster data. So here we're gonna have a let dragon, or let's do troll. So let troll equals monster data, and so then we have the parent. So parent is going to be a none. Health is going to be a let's say like 45. Trolls significantly weaker than dragons. And attack is going to be the troll whacks you in the head. Okay, so that gives us a troll. If I want something that like uses this other troll, then it would be let cave troll equals monster data. And we're gonna do parent is a sum of string troll. Now, this is a the reason I'm doing this is because we potentially be getting this information from a JSON object. And so we wouldn't know that it's like this specific troll data. We just know that it's grabbing out here, and we're gonna have to like extract out and then create these and then like do the next level. Like, so it's gonna be multiple passes over this. So then parent sum troll, we're gonna have health is 0 and attack is an empty string to indicate that we want to just take the base attack from here. So if we did this and now we want to combine them together to like actually make the monster information from this. So I suppose what I could do is we could just go back into main. We have our breeds. We have our struct. Here's main. Add you back in there. Let's get this information. We'll just delete you. And here we go in main. Okay, so we get troll from the monster data and the cave troll of the monster data that references this troll. Now what I want to do is I want to create monsters from this information. And if I can do this, then I can like extrapolate further and actually create that in JSON data, use JSON, import it, and then like automate the process a little bit more. So I'm sort of like going backwards from like the beginning. This is more like a check. Hey, can I do this? So first we want to make the troll breed. So we're gonna say let troll breed equals, this is gonna be a monster new, and oh wait, not monster, we want to breed. Breed new. It has a parent. Well, this one has new parent, but can I do this automatically here? We need to, let's see, monster data. I need to check if this is going to be just a troll dot parent. Just like pass that straight in there. The given health is gonna be the troll dot health. Well, that's not gonna work for the cave troll now because we need to do a little bit of logic to figure out how it's gonna how it's going to properly work. Because, yeah, I could just say, well, and also this has to be an option now with this. So we need to figure out how to extrapolate out and create the proper things to pass in to breed. So maybe this could be like another constructor on breed that takes in this monster data and then like figure that out. That could be interesting. So we have parent none. We have health. We have this attack. We have these things. Let's see. How do I want to deal with this? I would probably put this in a vector and then loop through them and then create my monsters. And then I can loop through, create the breeds and then create the monsters from the breeds. And then from those, I could then run the attack string off of them. I could definitely do that. We could use a hash map to store the breeds as we create them as well. But if I wanted to automate this, let's say I didn't actually, let's say this was like even an empty string, like static str. I think in JSON it's a string that it comes in as. So if I say your parent, you're an empty string if you're none. Otherwise, you're the name of the parent. So that would be troll. I would probably want, come on, string. I wonder if I need to like name this. Yeah, I think I'm gonna have to like think a little bit more about how I want to like extract this through, and maybe just like start from the JSON, and that way we can have like, okay, in our source, I want this outside of here. We want the monster data.json, and so here we have troll, and so this would be parent, nothing. We have health, 45, and we have attack. The troll hits you in the head. And then we're gonna have cave troll. And so cave troll is gonna be parent is a troll. We're gonna have health is 0 because it shares its parent. And then we're gonna have attack, which is maybe unique for this one, which is the cave troll maybe like swipes at you. A grimy hand at you. And right, there's no trailing commas in JSON. Okay, so if I have this, I would need JSON to like grab this file into main.js. We wouldn't have these. And we wouldn't necessarily have this monster data, although I think we would have to have this. These would have to be strings. And then we'd have to have JSON read monster data, then create this monster data from that. So we'd have to like tell Serde, okay, this is what the JSON is going to look like. Go ahead and pull that in. It's going to do the checking at runtime, and then it's going to give us the list of these. Which I wonder if these need to be... I wonder if I need to match these. It's been a while since I've used JSON. So this is something that I think I want to like look into maybe for like a game that we create with Rust. Then they can actually do this pattern for real, and then that might be a lot of fun. But I'm gonna remove this setup because I removed that. This monster data isn't really here. I don't think I can bring in Serde JSON that fast and use it. I only have 4 minutes left. If any of you have any questions about like the pattern of at least creating our own inheritance system, please ask and I'll be happy to answer that. Okay, so that's Serde JSON with that, operating untyped JSON values. That's always fun. Ours would be typed because we'd be able to control that ourselves. Now, how do I pull this in? Oh, we could just handwrite this in. I would have to go to a file. That's nice when like playing around with it. Parsing JSON has strongly typed data structures. So we'll have Serde, deserialize, and serialize, and Serde JSON result. Okay, so here's this person that we're gonna get in, and then we're serializing this. Okay, so there's this, R#. I'm not used to seeing strings that look like that. That almost looks like a macro, except it's not. Exactly the same function was produced by Serde JSON, value above, but now we're asking it for a person as an output. Okay, so that's like very similar to what we would expect here. So if I do cargo.toml, what is it? Serde JSON, what do you need to pull in? No, Serde and Serde JSON. Serde equals that. Serde JSON equals that. Use the latest. Use the latest. We have our monster here, which has a parent, which is a string. Wait, did I do the wrong one with strings? Breed. You're fine here. I did. Monster, we want you to be a... Wait, I thought monster we didn't need to be a parent anymore. We didn't need to store that. Monster data. Okay, so parent is string, attack is a string. We're gonna use Serde JSON. Oh, Serde deserialize and serialize. Use Serde JSON result. No deserialize and root. Wait, really? Did I misspell it? Let me just grab you. Make sure I've got it right. Unless the docs are wrong, in which case we have to go. Oh, capitalize D and capitalize S. That's what I missed. And now, can I grab... Okay, so we can get our data from this. So we can say, let... this is going to be sort of like the raw monster. I guess it would be raw breed data equals R sharp quote, and now I can put all this code into here, which means I can come over here and I can just grab you. Well, you certainly don't like that. So R sharp. Oh, hash at the end. Here. I've never used this before. That's pretty cool to sort of like put a string, a multi-line string in here. That's a fun thing. Okay, so that gives us our raw breed data. Now, the thing is here that this isn't really true, is it? Because if I'm going to ask it to create a monster data from this, it's going to expect that the entire object here matches this. Unfortunately, I don't have that. I would need to maybe make this an array of monster datas, and then we'd have to like loop through it and figure out which one was which. So how would I? Because we wouldn't know like how many we have, right? We like dynamically could have like another one, which would be like maybe a mountain troll. You need to be. And if we do something like this, now it's parent is a troll, and its health is 0, and its attack is 0. Or its attack is an empty string. The problem here is if I want like a dynamic number of these, this would probably have to be an array. So make that an array, make that a closing array. Now I'm gonna have to say, okay, give me an array of, these are gonna have to be troll objects. But the problem is now I don't know what they are. I have to put like the name or like type into them, and then constantly like search through, which is not quite as helpful. So I'd have to figure out like how I want to implement these and like control them in. I wonder if like RON, Rust object notation, I wonder if that would be helpful in this case. I know like this makes a lot of sense in JSON format where I could just have this be an object. And of course in JavaScript it's really easy to sort of like process this object and deal with it. Not quite as easy here in Rust. So I think that's gonna be like the next thing I wanna look into is how to deal with this and how to like bring in our objects dynamically. But as a quick recap of what we did do, before that is we created our own inheritance system inside of Rust. So give our struct monster, implement monster. Okay, so we create a new breed. And we have a possibility when we create the breed of passing in a parent. So we pass in an option for that. That way it can be something or nothing. If we pass in, we also have like the given health and the given attack. If we pass in health, we just take that. However, if we don't pass in health or attack, so nones for either of these, then it will reach into the parent and grab the parent's health. So we can see that here. Here we're gonna grab the health, and so, hey, did we pass in health? If no, check to see, did we pass in a parent? If we pass in a parent, get the health from the parent. Otherwise, panic. Hey, we need to have like health coming from somewhere. We do the same thing for attack. This allows us to down here create like a base dragon, and then create a green dragon based on that base dragon. So we have an inheritance system inside of Rust, famous for not having any kind of inheritance. And that gives us the ability to have like a little bit of a customization going on here. Now the question is, how can we dynamically do that? We haven't figured out how to do that right now based upon an external file like RON or potentially JSON, as I was experimenting with here, to dynamically create these instead of us having to do them in code. And that's what we did. So that's what we got for the stream today. So I'm gonna go ahead and put on a